Hi, Peter.
Hi, Carl. How are you?
I'm good. How are you doing?
Great, thanks. Yes. In New York City this morning.
Yeah, it's beautiful here. So I should introduce myself, and then Peter, you can introduce yourself for the people who are just listening on the podcast.
Right.
My name is Carl Zimmer, and I'm a science writer. I write a lot for the New York Times and other places about biology, and I appear fairly often on Blogging Heads.
And I'm Peter Pringle. I was, for 30 years, a foreign correspondent for mostly British newspapers. I've also written for the New York Times, the Washington Post. And I've recently became interested in agriculture, and I wrote a book about biotech agriculture, and now I've written this current book, which Carl will talk about.
Indeed I will, yes. So this book is called The Murder of Nikolai Vavilov. That's Vavilov. And I have really been enjoying this book. I love books that tell me about somebody that I never heard of, but I should have. So maybe, Peter, why don't you just give a little thumbnail description of Vavilov, and then we can really jump into the book.
Okay.
Who is he, and why should people care about him?
Well, shall we agree? Let's call him Nikolai. It's an easier first name.
Okay.
Well, basically, he lived through the 20s and 30s at the beginning of the Soviet Union, and he was a plant geneticist. He was basically in charge of all plant breeding in the Soviet Union, and he started the world's first seed bank in Leningrad in the 1920s, and using genetics, he set up plant breeding stations all over the Soviet Union, but he ran afoul of Stalin, and he was arrested along with other geneticists at the end of the 30s, and he died in one of Stalin's jails.
Yeah, I think a lot of people may have heard of Lysenko, Trofim Lysenko, who was sort of the Stalin's biologist, as it were. He rose to power under Stalin and basically sort of essentially declared genetics illegal in the Soviet Union. And a lot of people have been familiar with Lysenko for the damage that he did to science, particularly in the Soviet Union. But we don't really know much about his victims. And Vavilov, or Nikolai, I'll call him, if I can be so bold, is obviously... I didn't realize that such an extraordinary scientist was one of his chief victims, and it's I just find the book fascinating in terms for a lot of reasons, but one is kind of tracing science as Russia became the Soviet Union and then came under control of Stalin. In some ways it's terrifying, but in another sense you sort of can't put it down. It's like a car wreck or something. So Peter, I was sort of curious how you came about writing this book. Did you know about Vavilov?
No, I didn't. I was a correspondent for the London Independent newspaper in Moscow from 90 to 93, and I lived on a street named after Lenin's brother, actually, and many of the streets around where I lived were named after famous socialist figures and heroes around the world, including Ho Chi Minh, certainly. And one of these streets was named after Nikolai's brother, called Sergei, and I'd never heard of him either. But so I asked a Russian friend one day, "Who is this Sergei Vavilov?" And she said, "Well, he was the president of the Academy of Sciences under Stalin in 1940s. So he had a street named after him, which runs past the Academy of Sciences nearby." And she said, but actually his older brother is much more famous today than he was, and his name is Nikolai. And I said, well, what did Nikolai do? And she then proceeded to tell me how he started the plant breeding system in the Soviet Union, and how he ran afoul of, as you said correctly, Lysenko, and then eventually of Stalin, and ended up in jail. But I, for 10 years, sort of put this at the back of my mind. I'd left the Soviet Union, I'd come back to America as a correspondent, and I wrote this book on food called Food Inc., on biotech agriculture, and I came across Nikolai Vavilov. So I thought to myself, well, I wonder if there are any relatives alive. And it turns out that his son, Yuri Vavilov, is alive today, living in Moscow. He's a physicist. And so I called him up, and I said, I'd like to know more about your father. And he said, I'm just writing a book. You see, I've any direct relative of somebody who fell afoul of Stalin and eventually ended up in the jails and died, and then was rehabilitated, like Nikolai, can get hold of his KGB record. So I was fascinated by that, obviously, and I said, could I have a look at it, and do you have any more pictures, and do you have any more documents? And he said, yes. He said, there are 6 volumes of my father's letters just been published by the National Academy. And I said, good heavens, I'd love to see those. So off I went to Moscow to see him. So that's how it all started, basically.
Wow, that's amazing that there can be so much information, particularly about someone whose reputation was basically erased. I mean,
that's right.
I mean,
and of course,
I'm sorry, go on.
That's right. And under normal circumstances, when somebody gets arrested by in those days, NKVD, the forerunner of the KGB, everything is confiscated. Everything is, all property, all documents, everything is confiscated and usually destroyed. But in this case, there was so much of it, for one reason, I think, that they simply couldn't take it all, and a lot of it, by his very loyal staff in his institute in Leningrad, now St. Petersburg, was hidden in the basement, in the attic, and so survived. And we must be very thankful for them that they did that.
Yeah. I mean, the book, I should say, is it's not all about Stalinist persecution and a war on science, but the beginning sections are really more almost kind of a I don't know, you could call it like an agricultural Indiana Jones.
That's right.
I mean, Nikolai is he in the early years, he's going on all these amazing expeditions in search of plants and seeds, and he's really the first person, it seems, to really get the importance or to demonstrate the importance of understanding the incredible diversity of crops and their wild relatives. I mean, how did he develop this passion? I mean, how did he come about to decide that he was going to be going to remote parts of Afghanistan or Africa or all over the world searching for crops?
Well, he had this idea that if you're going to use Mendel's laws for plant breeding, and you can breed 2 different plants, and one is a very strong plant, the other is a weak plant, then maybe your weak plant will eventually become strong. Maybe you can search around for wild relatives of this plant, say wheat, say corn, say barley, oats, and you can, over a period of time, you can breed the perfect plant. And remember, this was way before biotech. So you're not inserting, you're not taking a gene out of one plant and putting it into another. You're breeding them in the normal way of sexual reproduction. So those genes are getting mixed, and eventually you want to refine it. So it takes a long time. But he looked around the world and he said, "Well, where should I go?" And literally spread out maps on his floor, and there are pictures of him actually with one of these huge maps. And he said, "Well, if I want to find out about corn, I have to go to Mexico. And if I want to find, because that's where corn comes from, and if I want to find out about potatoes, I have to go to Peru, because that's where they originated. And then about rice, I have to go to India or Southeast Asia somewhere. And wheat, I have to go to the Fertile Crescent, which is now, of course, Iraq and Syria, and then Mesopotamia before, and all the rest of it. And so he said, okay, let's set up these expeditions. And Lenin, the first leader of the Soviet Union, was in total agreement with this. He said, look, we have terrible famines in Russia, in the Soviet Union, and we have to put an end to it. And we have to somehow go to these places, find these wild relatives, and collect them, put them in bags, send them home, sort them, and then see what we can do with them. And so he did, and so off he went. And the first place was Afghanistan. Then he went all the way along the North African coast. Then he went to the Middle East. And then he went to Ethiopia, then Abyssinia, and then he went to South America. He went to all these places. Astonishing performance, actually, when you think about it, because the Soviet Union in those days had no money and no friends, and basically no diplomatic relations with any of these countries. So it was so he had to somehow create a passage for himself to bring together these expeditions.
Yeah, it's just incredible reading about some of these trips that he took. I mean, in your descriptions, he's on horseback going across these incredibly nasty, forbidding territories.
Right.
I mean, getting nearly falling into chasms, and then
That's right.
And then dealing with bandits and hostile governments, and taking planes and buses and boats and whatever he can get, whatever he needs to get to the next place, to get to that next field.
That's right. And there were a couple of stories I really like about that. One was when he went to. He goes off to America at some point, and obviously a good starting point. They have a big agricultural extension service. The government is providing seeds for the Midwest corn producers. So he comes to America, but he can't get any actual money. He can't get dollars. So Lenin says, well, you can take some precious metals, take some gold, take some platinum, and that's what he did. And he went to America with literally with ingots of gold and platinum in his pocket. When he arrives in New York Harbor, and every immigrant coming, every visitor in those days coming, had to have $300 on them as sort of starting money. Otherwise, they wouldn't let them in the country. And so he arrives, and he hasn't got $300. He's got gold and platinum, and the customs officer or the immigration officer, or whatever, says, "What do you think this is? Hey, who do you think you are?" So fortunately, he has a friend who he's able to cable, and they bring $300 to the dockside, and he gets into America. But it was like that all along. And also, you have that wonderful image which you talked about. Of he always wore, wherever he went, he was a product of the Tsarist professorial class, and they always wore a suit and a pressed collar and a tie and a fedora. And that's what you see him wearing. It doesn't matter whether he's on a horse in the middle of the Hindu Kush or wherever he is. He's still wearing a suit. It's a marvelous vision.
Yeah, I saw one of the pictures in your book. It's almost surreal. Yeah, he's in these incredibly forbidding mountains, just perfectly pressed, it seems. So he starts out really before the Soviet Union. I mean, and then he becomes one of the leading scientists of the Soviet Union. I mean, how does he make that transition?
Well, I think in those early days, Lenin's time before Stalin, there was many scientists, not only in Russia but outside, saw this experiment in socialism, I suppose you call it, as a way in which science could be funded for the public good, in a way in which it wasn't being funded for the public good in the West, because it was always tied to some commercial operation. So here was a pot of money, not much in those days, of course, but enough, and a centralized control of saying, what do we actually need from science? What's it going to do for us? And we can drop projects which we don't need, and we can control those which we do need. And in the end, Soviet science will supersede what's going on in the West. A lot of Western scientists said this is a great idea, and a lot of Western scientists actually went to the Soviet Union in the beginning and to join Nikolai. And Nikolai rose very quickly through that process after he graduated. He was a professor in Saratov, smaller town on the Volga for a bit, but then he was in charge of all agricultural plant breeding, and it looked to him, even when he came to America, it looked to him as though he still had a better chance of creating a better system for plant breeding in the Soviet Union than there was in the West.
The other thing I found interesting about that stage of his career was that this is really the dawn of genetics, and I guess I'd sort of forgotten just how important people who were studying genes in plants, plant geneticists, botanists, how important they were to genetics, to the science of genetics. I mean, after all, Mendel was crossing pea plants,
right?
And so that's in the I guess the 1860s, I guess, and
yes,
and
that's
then
right.
His work is forgotten, and then it's revived again in around 1900, and a lot of people who are doing the reviving are studying plants.
That's right.
So Vavilov was. It seems like he was pretty clearly just embracing this new science of genetics, as opposed to these other ideas kind of left over from Lamarck about how you might acquire a character in your life and then pass it on to your offspring.
That's right.
He was. Did he just recognize the importance of genetics and Mendel from the start, or did it take a while?
Yes, he actually he latched onto it, if that's the right phrase, right from the beginning. And he had a couple of progressive teachers at the agricultural college that he went to, which was pre-revolution times. Then the norm was that if you were going to go on to be a professor in science of any kind, you would be sent to Europe. Because that's where the serious work was going on. And so he went to London, and he joined up with the Cambridge scientists, and also the London scientists. And then he also went to Paris, and he went to Berlin, and so he, in about 12-month period, just before the start of the First World War, he was able to get himself up to speed, if that's the way to put it, on genetics and the latest cutting edge of genetics at that time. which of course we must remember was still, we've only just discovered, we've only just named it genetics, and we've only just named it that curious thing that passes during reproduction. We've only just named them genes, and we can see chromosomes under the microscope, but we can't see genes. So what are these genes? So actually, it's very early days, but he was quite determined to use it and to superimpose it on plant breeding.
Right. I guess at that point, I mean, it's easy to forget now that we have all these genomes and DNA scanning, but I mean, at that point, basically what you had to do is genetics was breeding. I mean, breeding was the only way you could study genetics. So you you might take say a bunch of white and purple flowers and crossbreed them, and then you'd have just a bunch of purple flowers, and it seemed like the white trait was gone, but then you'd breed those purple flowers together, and bang, you've got some more white flowers in the next generation. So that's how they would track the genes, whatever these genes were, from generation to generation.
That's right. And of course, there was a very sort of simple idea about genes. One gene equals one trait, a la Mendel, as it were. And that, there's one gene for blue flowers and one gene for white flowers. And so if you mix them up together, you'll get a dominant gene, whichever it is, white or blue or pink or something, will come out first. And then the recessive gene, as Mendel saw them, would come out last. But they'd still be there. But in those days, as I say, one gene per trait. So if on his expeditions in Afghanistan he spotted a particularly tough-looking plant of wheat or rye or something, and he says, "Well, I'll have that one." Puts it in his bag, takes it home. But it doesn't necessarily mean that just because he breeds that to his plant and back in Russia, which is not so strong and good-looking and fruitful, that it'll work. And of course, they never knew in those days that it takes more than one gene many times to produce a trait. In fact, always. So.
Yeah.
Just early days, but and terribly exciting days. I mean, what was the chromosome? What part did it play in reproduction? Where were the genes on the chromosomes? And so most of this work. This early work, particularly on chromosomes, was eventually done in America. So he had to come to America. So he visited the laboratories of Thomas Hunt Morgan, for example, at Columbia, where he was working on fruit flies. He's an eventual Nobel Prize winner. And he was a great networker. He. In days also, one must remember, barely with the telephone in the Soviet Union, and sometimes with the telex if it worked properly, but not the internet or anything like that. You couldn't pick up the phone, and you had to write letters, and he was a fantastic letter writer. Up to 40 letters a day he would write off to his friends all over the world. Amazing man.
Wow. And the other exciting thing that came out of his research then I found was this quest for the origin of agriculture, for where the first crops came from. I mean, that seems really remarkable how he ended up with some pretty good guesses about where different crops had originated.
Yes, he really did, and he came up with, I think, originally sort of about 5 or 6 centers, and then made them 8 centers. And we're talking about, as I mentioned earlier, we're talking about corn from Mexico and potatoes from Peru and wheat from the Middle East. But he had this big chart on his desk, and in my book there's a picture of him with this big chart, and he called them centers of origin. And now, of course, they call them centers of biodiversity, but they call them centers of origin. And they've been shifted around a little bit, and sometimes they're 8, sometimes they're 5, sometimes they're 6. But what he did, and what his great legacy was, I think, is to say to everybody who was involved in this plant breeding process, look, we can't just talk about botany. We have to talk about geography. We have to talk about archaeology. We have to think where the first farmers farmed, and does that mean that's where the greatest biodiversity would be, and that's where we should look for all these wildflowers, or what? And should they be down in the fertile plains or up in the mountains? And that was a genius vision, actually, at the time.
Yeah. And then he ends up just running this army of agricultural scientists, and there are all of these experimental stations where he's trying out all these different crops that he's found, and he's also building a huge seed bank. I mean, all these seeds that he ships back, he just sorts them, and his staff stores them away. So, is this unusual at the time, like to have a seed bank? And how did this seed bank he had compare to other collections?
Yeah, I mean, very unusual at the time. And another visionary event, if you like, it was the first seed bank to contain all, actually in the end, 270,000 seeds of agricultural crops, food we eat, basically. Other seed banks had been, for a much sort of wider range, to include vegetables and flowers and other plants, but this was totally devoted to food crops. And his idea was, one day I'm going to feed the world. I'm going to feed the Soviet Union first, and then I'm going to feed the world. And that's what he wanted. And if anybody asked him how long this would take, he'd say, at least 100 years. But it became the envy of his colleagues around the world, this center that he set up in amazingly in an old Tsarist palace in the middle of St. Petersburg, then Leningrad. And it still exists to this day, still there.
Wow, that's amazing. So, so then things start to go kind of bad for Nikolai. You seem to you find that transition. Correct me if I'm wrong. When the Soviet Union starts encouraging these sort of bringing up, I guess you could call them like peasant scientists. The people they have this kind of hostile attitude to sort of bourgeois academics, and they want to bring up these sort of proletariat heroes, including Lysenko, and they start being very critical of Nikolai.
That's right. Well, this change happened. Lenin was never enamored of the bourgeois class that Nikolai came from, but he realized that there wasn't anybody else, and if you're going to create a good scientific base, you have to use these people until you have brought up your own people, as it were, from the peasant and the proletariat classes. So the changeover happened towards the end of the 1920s, and Lenin died in 1924, and Stalin took over, and in 1929 Stalin declared famously that this was the great break with the past, and with what he really meant was with the West and with Europe, and the Soviet Union and Russia would continue on its own and do its own thing and have its own technicians and scientists brought up from the classes that had been oppressed under the Tsar. So one of those people was this curious person, Trofim Lysenko, who came from the Ukraine, and he had a minimum education. He was a sort of horticulturist, knew how to plant tomatoes, which he started off doing very well, and he obviously had what we call a green thumb, could spot a really good plant at 50 paces or whatever, and so he started to have this reputation as being good at selecting the right plants, had no scientific education, didn't know anything about genetics, never learnt anything about genetics, but simply said, if I treat these plants properly, and if I give them the right light at the right time, and the right water at the right time, and the right heat at the right time, then I will be able to improve the way in which they produce their seeds and improve the yield. So that's what I'm going to do. And Stalin understood this. He didn't know anything about genetics either. And so he understood this. So he started to favor Lysenko over Nikolai Vavilov. And it got very heated. And it got, the more they got into geneticists come from that bourgeois class, the worse it got. And Stalin added that, genetics is just being used for horrible things in the West, like producing master races, a la Hitler, etc. So genetics got this incredibly bad name in his mind, and to say that he actually ended up thinking it was a bourgeois plot is carrying it too far, but that's the idea. Yeah. And Lysenko was the head of and the symbol of these peasant scientists, and got promoted as such.
And it was also interesting how just the whole notion of this kind of Lamarckian change, that these traits were very changeable, that the environment could change them. I mean, that's there is a certain amount of truth to that, in the sense that if you grow a plant in different places, it's going to grow in a very different way. It's got that built into its genome, but the idea that those sorts of changes could be passed down genetically. Right. Well, I shouldn't say genetically. That they could be passed down through heredity. It's interesting how that really really struck a chord in the sort of with Stalin, or with sort of a general kind of ideology at the time. I mean, along with eugenics, I mean, they really felt like genetics was just bad for it didn't fit with communism, I guess they were feeling at the time. It's really interesting how those sorts of attitudes, that it seems like they kind of fed this rise of Lysenko. Would you say that's true? Yes,
I mean, it was part of it. It wasn't the reason for it, but the idea of Lamarckism, which is, as you say, that acquired characteristics during an organism's lifetime, a plant or a person, can be then passed on to the next generation, which we all know not to be true, and they knew then not to be true, thanks to Mendel, was attractive to the socialist idea of building socialist person by training them, if you like, in the right direction, and so that they would acquire this the bent that they wanted, and that would be passed on to the next generation. Was a very attractive idea. I mean, how many of them actually believed in that, or whether it was just it was just nice to have it there, sitting there. It's hard to put a finger on that, but and so it wasn't the only reason. It was just a more convenient reason. If you add that to the idea that genetics comes from the West anyway, we don't want anything to do with that. We want to build our own Soviet biology, not Western biology. Then that all comes together, and it's a powerful mix by the time they put it together.
Yeah. Another thing that struck me about this conflict between Lysenko and Vavilov is that it sort of resonates with science today, in the sense that there was a lot of pressure on Nikolai, on Vavilov, to stop being so distracted by theory, by these sort of abstract questions about genetics and about plants, to stop going off on these expeditions to answer these seemingly academic questions, that there's this big pressure for him to deliver. That Soviet Union is starving, and they need crops, and they're putting all this pressure on him to deliver. And Lysenko, who has no compunctions is saying, "Oh, sure, I can do that. I can give you a super crop in a year because I just raise it bury it in the snow or something, and boom, I've transformed it."
That's right. Well, of course, the turning point was really the 1932 famine, which was largely man-made. It was Stalin and his collectivization of agriculture, getting rid of all the efficient farmers because he saw them as part of the old system, bringing up the peasants. And, of course, the peasants weren't properly educated in how to use the new techniques for plant breeding and for increasing varieties and increasing yields. And it was a total disaster. In 1932, 5 million, 5 million or more died during that famine. And Stalin needed an excuse. And he needed to rectify it, to not have it happen again, and he needed an excuse. And the excuse was these geneticists who've been in charge of this thing for the last 10, 15 years have done nothing. They've not prevented famine like Lenin thought they might, and they take too long to produce new varieties, 10 to 12 years or something. And so Lysenko, spotting this opening, said, good, I'll have that one, thank you very much, and began to create a totally fraudulent path. And it is different from you were right to say, and it's important to know that, he wasn't a complete charlatan. You can do all kinds of things with plants according to how much light and heat and water you give them, but you can't change them. You can't change them into something different. And he then said to Stalin, "Don't worry, I can do that. Give me 3 years." Of course, in 3 years he hadn't done it, but in the meantime, in those 3 years, Nikolai hadn't done it either. So Stalin said, "Well, maybe we'll give Lysenko another chance." And obviously, he preferred Lysenko to Nikolai, and it just simply got worse as time progressed through the 30s.
Right, until Nikolai was thrown in jail.
Yes, and they had debates. They had long, rancorous congresses, and all the things that you can imagine about what riddled with Marxist rhetoric and obeisance to Stalin and all the rest of it, and of course getting absolutely nowhere in the science of it. And Nikolai getting more and more frustrated, and his friends abroad seeing him getting frustrated, and finally, having done all this traveling to 5 continents with ingots of gold and platinum in his pockets, he wasn't allowed to go abroad anymore. He was restricted like everybody else, like all the other scientists were, and finally he gets arrested and thrown in jail. Yes.
And this is only after he's watched a lot of his staff and his colleagues getting arrested, thrown in jail, in some cases executed. I mean, it's surreal how long this decline went on.
Yeah.
I'm reading it. I'm just thinking like, oh, for crying out loud, let's just get over with.
That's right.
You know, it's not going to end well.
Yeah. No, it gets worse and worse, and he gets more frustrated, and Lysenko gets more dictatorial in his own works, and science simply goes out of the window. And so, in 1948, which is after Nikolai's death, but 1948, it's decreed by the Politburo, Central Committee, and everybody else saying, Lysenko's way is correct. Soviet biology should be run by him, and geneticists, goodbye.
I spoke recently to a Russian biologist who, he would have been quite young back then, but he was talking about that 1948 conference and about how that was such a shattering moment, and how there were a lot of Western scientists, as you mentioned. There were Western scientists who thought that that science might progress well in the Soviet Union because of the way that they were organizing it, and they kept sort of turning a blind eye to what was happening under Stalin. But finally, in 1948, they just sort of threw up their hands. I mean, they just saw that it was all over.
That's right.
It's just
That's right.
it's just so tragic. Vavilov died in 1943.
43.
Is that right?
Yes, 43.
So that's during the war. I mean, that must have.
That's during the war, and there's an interesting idea during the war that his collection of seeds in Leningrad had become so famous and so sought after by Westerns, including the Germans. And the Germans invaded Soviet Union in 1941 after the pact that they'd had, and marched very quickly towards Moscow and towards Leningrad. And Hitler created a special SS commando unit who only had one task, and that was when they got to Leningrad, go and get all the seeds, all Nikolai's seeds, pack them up and bring them back to Germany. Well, of course, they never got to the center of Leningrad because of the siege of Leningrad lasted 900 days, famously. They never got there. But there was a problem also at the seed bank itself because people were starving. People, and to find a potato, to find a bag of rice seeds was something was irresistible. But the people who looked after Nikolai's seed bank died at their desks, a dozen of them, rather than destroy the collection. Amazing.
They starved. Are you saying they starved?
Yes, they starved to death at their desks rather than destroy the collection.
Surrounded by hundreds of thousands of seeds.
Yeah.
God.
Yeah.
Oh.
No, it's an amazing event.
So, it's very strange today in a lot of ways to read about this. In part because, as you say, I mean, Vavilov's reputation has been quite restored in the Soviet Union, and at least among plant scientists, and I mean, so many of his ideas and his achievements have been built on. I mean, so we were just talking about the origins of agriculture. I mean, that's a huge area of research these days. I mean, you have all these archaeologists and geneticists and so on working together, trying to figure out, exactly, not just that corn originated in Mexico, but maybe it originated in this particular valley in Mexico at this particular time. And seed banks too are really important as well. I mean, and there's been a lot of stuff about seed banks in the news recently. Maybe we could talk about that for a bit. I mean, there's this one seed bank that opened up in this Arctic island. Right.
The Norwegian island near the Arctic Circle, within the Arctic Circle, I think. They got some money together from Kerry Fowler from. Attached to the FAO in Rome, and they got the money together, some of it from the Gates Foundation, built this seed bank where underground in this mountain would be the perfect temperatures, low temperatures, to stop the seeds decaying as fast as they would if they were in the open air, as it were. And but there's a slight problem with this seed bank. If you compare it with Nikolai's seed bank, he basically said, okay, this is going to be for Russia, and then it's going to be for everybody. That was his dream, because it didn't happen. But the seed bank in Norway also contains seeds from agribusiness companies, which are genetically modified, which are therefore, the agribusiness has put all its research into these genetically modified seeds, and they're not going to let anybody have them unless they pay for them, unless they pay royalties on the patent. So there lies the difference between then and now, if you like. And the important thing to attach to this also is that there should be seed banks around the world, and there are actually run through international organizations attached to the UN in some way that allow access to those seeds to any farmer in the world. And he doesn't have to pay for it. It's just there if he wants it. The question is whether that money will continue because it's government money, will continue in the same way that it has been in order to keep those seeds viable and in order to increase it and increase the numbers in the bank. So it's a problem.
So, are farmers going to these seed banks frequently? I mean, are they a resource that's used a lot, or are these sort of things just sort of stored away under lock and key and very grudgingly opened up?
Well, they are. For example, I mean, I think probably one of the more famous ones is the one in the Philippines, where for many years there's been a research institute which does its own breeding of rice, produces the seeds, makes the seeds available to farmers around the world, but it's had its budget cut very recently and over the last couple of years. So there are certain seeds which need testing, as Nikolai tested his over a period of 10 or 12 years, and they don't have the money to do it now. Although it is available, and though they've done the research, they know what genes are necessary to put into the new plant. There's a backlog of work, if you like, and which is not being funded.
And from what I understand, there's still a lot of work to do to find a lot of these varieties of various crops and their wild relatives. I mean, there's still a lot out there that Vavilov and Vavilov's intellectual descendants have not gotten to. But
that's right.
They're also disappearing quickly, right?
That's right. I mean, I think the latest estimates are something like 3/4 of the genetic varieties of food crops that existed 100 years ago, i.e., in Nikolai's time, don't exist anymore. They've just simply disappeared.
And now is that because farms are being converted over to just a few?
That's right.
Particular varieties from these big corporations.
That's right. Well, basically, I mean, we humans eat from the 10,000 varieties that were available to the early farmers 10,000 years ago. We have selected about 150 of these crops, and we use 12 of them as the major staples. And of those, only 3 or 4 or 5, rice, maize, corn, are used in about 60% of the food that's produced in the world, across the world. So that's an incredibly small number compared with what's out there. And every now and again, if we continue to use those crops as we do, then they get a disease, and the disease has to be combated, and the only way to combat this disease is either to pour chemicals on it or to change the genetics of the plant. And the preferable way, obviously, one would say, would be to find a wild variety of that rice plant that somehow copes with this disease or this drought or this parching sun or whatever it is. And so, yes, there is, when you always get down, when everybody says, there's a problem with the food supply, well, they have to do various things. There's a list, reduce the oil prices, don't make so many biofuels, the population increases, and so it's going on. But the other one is, we still need to do what Nikolai Vavilov was doing in those days. We need to go out and look at the diversity of those plants in the centers of origin that he talked about. So that's a sort of extraordinary full circle after a century that you come back to.
Yeah, and it's there are a lot of interesting kind of echoes that the book has. Like, so for instance, Vavilov goes to Mexico, and he's looking for this plant that might be kind of a substitute for rubber,
right?
And then he wants to bring it back to the Soviet Union, and you mentioned that I guess the U.S. Was trying to spread bad feelings about the Soviet Union through this episode by saying that he was coming to sort of steal their genetic heritage. There's the same kind of
exactly
the same kind of rhetoric is used now, for corporations and for governments that seem to be working at their behest when they go into the rainforest doing screenings for plants or microbes, and then in some cases patenting the genes, and people are being accused of biopiracy.
Right.
It's just interesting to see that kind of accusation was being used by the capitalists against the communists back then.
Right. That's right. Yeah, I mean, I for capitalist reasons, very good ones. Saying keep this agent of communism out of our territory. No, but you're quite right. The same thing. So we have the international agreements on biodiversity. We have they're not perfect, but we're working towards them. Whose genetic resources? Whose are they? Are they the country that has them, or are they the property of the person who finds them? What do you do if the person who finds them goes away to an agribusiness corporation, makes something new, and then wants to sell it back to you? These are very difficult and complex problems that are being worked out in international law, and it's hard to know where it's going to end up, frankly. I mean, the basic problem is the patenting, isn't it? I mean, if a corporation spends an enormous amount of money on R&D and comes up with a very good plant that is so much better in yield and its resistance to disease than the plant before, and it's needed very desperately in a country, Africa, for example, but the Africans can't pay for it. What's the moral dilemma here, and what's the morality of it? Is that corporation just simply going to stick it on the shelf and say, well, they can't pay for it, so I'm not going to give it to them? Or does government step in, or does some philanthropist step in like Gates, or is there some different system that you can set up where everybody puts their patented plant into a commons pot of some description, and then everybody can take it out and somehow put it back, and if you can't pay for it, you can have it on a humanitarian basis. I mean, all these questions which didn't really, you're right, didn't really exist in Nikolai Vavilov's day are now very much front of the picture here.
Yeah, and it's a far cry from what Vavilov had in mind. I mean, in many ways, he was a communist scientist in the sense that he believed that he was, he was bringing these seeds together to feed his nation and then to feed the world, and he wasn't laying the groundwork for corporations to get patents. No,
that's right. That's correct. Of course, they didn't have patents in the Soviet Union in those days, so so it's a different world. But the principles are the same, aren't they? I mean, you've got to go out there. You've got to find those wild relatives of those plants with the genes that you desire, exotic genes, if you like, and then you've got to stick them into the plant you're actually producing your food.
Right, except that, I mean, Nikolai would cross plants, and so like a whole set of genes from each plant would be combined, whereas
That's right.
now scientists are saying, oh, I like that one gene or
That's
these
right.
two genes. So there's this project to make rice with vitamin A in it, and they
That's
grab
right.
a gene from a daffodil and a
That's
gene
right.
from another.
That's right. Golden rice. You're talking
Yeah.
about. That's right. Yeah, exactly. Yeah, same thing. Yeah.
But so I mean, you've written a lot about all this. I mean, where do you see genetically modified crops going in the future? I mean, here in the United States, there's been some opposition, but farmers have been planting a lot of genetically modified crops. In Europe, there's been a lot more conflict, and there's been a lot more. The opposition to it has been more successful, and it seems like in some parts of the developing world, there are a lot of genetically modified crops being planted. Is this here to stay? I mean, what do you think?
I'm sure it is here to stay, and I go down the middle on this debate, which means that you get attacked from all sides. But I think it's the only reasonable course. I mean, obviously there are the initial concern was, are they safe to eat? It appears that they are, basically. There were concerns over whether by transferring one gene to another plant, an alien gene, if you like, that you'd create some kind of the product would be possibly harmful or even create allergies. But we haven't seen this in 15 or almost now 20 years of biotech agriculture. There's another greater concern, I think, about whether you might destroy those wild varieties simply by genes being transferred from one to another. Another genetically modified corn plant in Mexico would have this pollen, which then infected the original wild plant that you still wanted to preserve, and somehow change it so you would lose its properties. That's a very real concern, and rightly put forward by those who would be against genetically modified foods. On the other hand, there are certain ways now that they've discovered of taking the gene that would make a rice plant hardier in brackish water, which we're going to see from global warming, in perhaps less water, which we're going to see from global warming. That would increase its yield, that would, in Africa, that would get rid of a plant virus which attacks the root. I mean, if they can find resistance in other plants, genes of resistance in other plants, and transfer them, I have to ask the question, what's wrong with that? The only thing, and you could come back and you say, well, it's perfectly fine that they've done that, but why are they charging people who can't afford it and who are starving money? Why are they charging them royalties? Why can't they just give it to them? And so that's another discussion. So we're in, I think you're going to get a mixture of genetically modified foods and original foods and traditional foods, but in some cases, there are people in this world who can't. They don't have the money to pick and choose to be a vegetarian. They don't have the money to pick and choose to not have the plant that will produce the greatest yield. So it's a matter of necessity in some cases that GM foods will continue.
Yeah. My one concern, well, I have some concerns, but one of them is seeing science as a solution to things, to problems that are not fundamentally scientific.
Right.
I mean, I just wrote this book about E. coli,
Right.
and there I write about sort of the birth of genetic engineering, and I was really struck by how in the 70s, genetically engineering E. coli, it was very controversial, just like genetically modified crops are today. And one of the big applications that was being touted was to make E. coli produce human insulin. Stick a human insulin gene in there, and there you got this great supply of insulin. Wonderful.
Right.
And so that'll help diabetics. So, now it's 30 years later, and yes, indeed, we've got lots and lots of insulin at the ready from E. coli, but that hasn't brought the rates of diabetes down. I mean, in fact, the rates of diabetes have been shooting up, and the reason it's been shooting up is because of a totally different set of causes about how food is produced and how people eat it and their lifestyles and so on. And there was no way that genetic engineering could address that. And I see something similar with sometimes with these food situations. I mean, in your book you write about how, I mean, a lot of the famines under Stalin were not necessarily caused by bad seeds. They were caused by Stalin's crazy ideas about how to farm.
Yeah.
And shutting down the old farms and creating new ones, and it all sort of falling apart. And it's just it's like this was to some extent a man-made disaster. And it seems sometimes that at least some of what we face today with rising food prices and food shortages and so on and so forth, these are the man-made problems. And just to say, oh, well, we'll create a magic seed that will take care of all our problems, that's not going to fix it.
No, it's not going to fix it. And just let me preface by saying it's a great book that you wrote on E. coli, and return the compliment. But you're right. I mean, science cannot produce the magic bullet to end famine. Famine is caused by all kinds of things. In Stalin's case, man-made through the collectivization of agriculture. Today, famines, the current food shortage and food crisis is created by the rising price of oil, is created by agribusiness companies moving into biofuels, taking land that previously had produced corn for people to eat, now producing corn to make biofuels. I'm not saying it's a bad idea to have biofuels, but there has to be some kind of regulation here, balance here, thought, planning, and all the rest of it. So, yes, science, science cannot produce the answer to everything, but it just has to go into the mix. I think that's where we end up. And I think to say simply because it's not what we're used to, and it's not what, and we don't know about it, is not a good reason to reject it, or even to be too suspicious about it. I mean, I think we're not against. It's not the sort of lack of knowledge that is the problem usually, although it is. But it's also it's that people resist change for various different ways. Human beings are a very conservative lot, like all animals. Once the mutant comes along, well, what's he up to? What's he doing? It's a difficult question. And it just swirls around. It's a fascinating question, and I wish that more people were involved in it, actually, where I am, which is somewhere in the middle.
Yeah. Well, yeah, no, it is fascinating, and it does. We could talk for another hour or hours about it, but it looks like we should probably wrap this up now.
Okay.
But Peter, thank you so much. This has been a lot of fun talking about this, and I really I hope that a lot of people check out the book, because I learned a lot from it.
Well, thank you very much for having me, and for your interest.
Okay.
And good luck with yours too.
Thanks. All right. Take care, Peter.
Bye-bye. Bye.